Okay, so what's the difference between these two again?
Well, is that a force of attraction?
What do you think the sticks stand for?
A bond.
Bonds. Covalent bonds. Yes, this has a double bond. Very good. Guess what this has?
A triple bond.
Triple bond. Guess what this has?
Just a covalent bond.
No. Single bond. The electron repulsion is too great, so it destroys itself.
What?
But as far as I know, it's never happened.
Wait,
in other words, it doesn't even try to happen because it can't.
Wait, what?
A quadruple bond.
I got quadruple bonds in my muscles, actually.
Oh, okay. Well, be careful, they're going to blow up. All right, so you got single bonds, you got double bonds, triple bonds. That reminds me of a guy who injected steroids directly into his biceps until they blew up.
Yeah. I watched the whole
Real smart.
And then he like dreamed.
He looked so weird.
And then he was juiced
It's
up.
like he had two huge pistols.
It was disturbing. So anyways.
Wrestling match, my arm started
How did you do that?
They were like so full of blood that I almost started.
Honestly, why did
Yeah, that
you go and
happens
do
sometimes.
steroids? It doesn't make any sense.
All right, focus here.
100 pounds.
Back to this. Sorry, didn't mean to bring that up, but made me think of it. Back to this. Single bonds, double bond, triple bond. Which table in front of you, P or Q, talks about single, double, and triple? Not talks, but shows.
Q.
Q. Table Q has 3 series of hydrocarbons. It's called homologous series. That's how you say that word. The title, homologous series of hydrocarbons. So I'm not starting out with any notes. I'm starting with talking about tables P and Q and these molecules to help you understand. So Q is really important because it explains why this one has single bonds, this has a triple, and this has a double. Sometimes that happens. Yeah, that's kind of loose. Whatever. Back to P though. We'll get to Q in a second. Let's go back to P. P is prefixes for organic molecules. So this one, for example, has one black one. What's the black one? Carbon. What would the prefix for this name be?
C.
Look at table P. One carbon. What would the prefix be?
Meth.
Yeah, meth.
You know.
Okay? This has 2 carbons. What's the prefix for 2? Stop. What's the prefix for 2? F. Now, I don't have one made with 3, but what about 3 carbons? What's the prefix? People want to say prop. It's prop. Prop. What about 4 carbons?
But.
Yeah, people want to say but. It's bute. It's bute. Now, let me give you an example of how you won't forget this. The gas that's coming out of those...
Butane.
What is it?
Butane.
No.
Butane. Butane.
What's the gas some people have at their house?
Butane.
Propane. So it's prop, not prop. You don't say propane.
Oh, it's
okay? It's propane. Propane is an organic compound with 3 carbons in it. Prop. Butane is another gas. I know sometimes lighters have it in it. So butane is an organic compound. Looks just like this, except 2 more carbons. This is ethane. 2 carbons, and we say ethane, and I'll tell you why in a little bit. What if something has 5 carbons? What would the prefix be? Pent. It would be pentane. Like a pentagon. 5, right? Pent. And then 6 is hex, 7 is hep, 8 is oct, 9 is non, and then 10 is dec. So decane would be 10 of these carbons all linked together. What?
What about 11? Does that have a prefix?
Dosima.
You know, I used to know all of them, and then since I don't use them anymore, I don't teach it, I forget. But it's like a combination of the other ones.
You used to have to teach it, now you don't.
No, I used to, when I was in college, we used to have to know those. Now,
how many did you have to know up to? How many did you have to know?
Even in AP Chem, we really don't talk too much about organic stuff. So anyways, I forget. Sorry. Anyways, back to this. So this has a single bond between the 2 carbons. So if I was to draw this on paper, what it would look like is this. Oops. 2 carbons, single bonded, H here, H here, H here, H here, H here, and H here. You guys are going to be doing this very soon. So what are you going to be learning? How to draw, how to name it, and then how to use the molecule kits. So both. So if I was to write this on the board and I said, okay, what's the name of it? First step, how many carbons? 2. So then you go to your prefix, table P, and you say, okay, that's F. But now you go to table Q. So if you go to table Q, I want you to look at the general formulas. So you're not looking anywhere else except table Q. Look at the general formulas. For the alkanes, that's how you say the first one, alkane. The general formula is CnH, you can look up here, 2n plus 2. So there's your alkane. Now if you go back to table Q, look at the alkenes. That's how you say the next word. Alkene is CnH2n. So CnH2n. And then the alkynes, that's the third one. That's how we say it, alkyne. The formula is CnH2n minus 2. CnH2n minus 2. How do we use the formula? What is it for? It's so we figure out what to name this. So let me explain. We have 2 carbons. Look up here. 2 carbons. How many H's? 6. So if we plug the number 2 in for the N here, if we use this formula, it would be C2H2 times 2 plus 2. If we plug the 2 in here, it would be C2H2 times 2. And then here would be C2H2 times 2 minus 2. Oops. So a little algebra here, I guess, sort of. Not really. Okay? So, I did that wrong. Bear with me here. Okay. So if we do 2 times 2 plus 2, what does that equal? 2 times 2 plus 2.
That's confusing.
6. This is 6. What's 2 times 2?
4.
That's 4. What's 2 times 2 minus 2?
No, that's
2. So this matches this formula. This equation, this molecule matches this equation, C2H6. So I know this is an alkane because it matches that general formula. Since this is called an alkane, stay with me, this is really important, the first time you hear this. Since this is an alkane, the name of this is F-ane. Because there's 2 carbons, it's F, but because it's all single bonds, it has this formula. That's an ane, F-ane. F-ene would look like this. That would be called F-ene because 2 carbons is F, and then the E-N-E because it matches this formula, which is an alkene. 2, 4. So 2 C's, 4 H's. And then this one would be called F-ine, which would look like this. Triple bond with an F and then a Y-N-E. So the A-N-E is all single bonds, the E-N-E is a double bond, and the Y-N-E is a triple. You don't have to memorize any of this, it's on table Q. I'm just explaining what table Q is. So that's kind of where we're starting, is tables P and Q. And I will give you kind of like notes in order. I'm kind of just doing random examples, but I'm starting with this so you have some sort of idea of what we're learning here and visuals here. So F-ane looks like this, all single bonds, 6 hydrogens, 2 carbons. F-ene looks like this. That's the same thing as this, double bond with the springs there, and then the 2 H's on either side. And then F-ine looks like this. Just 2 H's with the triple bond between the carbons. So table Q is really, really helpful because 1, it helps you remember, okay, single bond, that's your alkanes, double bond, your alkenes, and your triple bonds are your alkynes. That's how it helps with that. And it helps with naming and drawing formulas. Why? Because you can use the general formula. So I know I'm going kind of quick and you're not picking all of it up, but I'm trying to just get the ball rolling with how to use tables P and Q. So to name something, you use the prefix, and then you figure out, okay, which series is it? Alkane ends in A-N-E, alkene ends in E-N-E, alkyne ends in Y-N-E. So this is where we're headed. We're going to start with alkanes and alkenes. We're only going to do a little bit of this, but we'll mostly focus on these 2. Now, if you look at table Q, the title, homologous series of hydrocarbons. Bree, what's a hydrocarbon? Yes. This right here is a hydrocarbon. It only has C's and H's. Hydro means hydrogen, carbon means carbon. So a hydrocarbon only has carbons and hydrogens. This is the simplest molecule that can exist as an organic molecule? What is it?
Carbon.
CH4, good. What's the name of that? It's all single bonds, and it's one carbon. Methane. It would be methane because it fits this equation. 1, and then 2 plus 2 is 4. So CH4 fits that, so it's an alkane. This is methane. Simplest organic structure right here. Now, how many bonds are coming off of this carbon? The black one. How many sticks coming out of the black one?
There's 3.
4. How many sticks coming out of each carbon here?
Wait, how is there 4?
Each black one. How many sticks are coming out?
Oh, I got it.
Wait, how is there 4? There's 3.
1, 2, 3. Whoop. 4.
Yeah, my bad.
Okay.
My bad.
How many coming out of this? Out of these two? Each.
1, 2.
1, 2, 3, 4. 1, 2, 3, 4. How many coming out of each black one here?
1, 2, 3, 4.
Okay, the answer's 4 every time. Why?
Because.
Because there's only 4 holes.
Very good. Where's my? I thought I had the thing. It's down there. So if I took this apart, all the yellow ones only have 1 hole, and all the black ones have 4. So that's the literal answer. But let's get the chemistry answer. How come carbon makes 4 bonds?
Carbon can only hold 4 bonds.
Oh, but that's
can't-
how many electrons.
Close. You're close. She said that's how many electrons. You forgot one word.
Valence.
Valence electrons.
Yeah.
Very good. Yeah, it has 4 valence electrons. So when you draw these molecules, you have to have 4 bonds going off of each carbon. You can't have 3, you can't have 2, you can't have 5. So if I stuck another hydrogen up here, that's wrong. That can't do that. Can't happen. 1, 2, 3, 4 bonds. So every carbon must have 4, and it can't have less or more. Has to have 4. Okay? So if I took the hydrogen off of this thing would basically self-destruct. It could not exist in real life. It has to have 4 bonds. Okay? You guys ever hear of free radicals?
Wait, what?
Free radicals. Like forget chemistry for a second, think real life. You ever heard the term free radical?
I'm one of those.
Yeah, for sure.
Not really. You said yes. Do you know what they do or what they are? You heard? Anyone know what they are, what they do, where they're found?
They are found in East Asia. And
They're in your body right now.
oh.
So free radicals are in the air, they're in the food we eat, they're everywhere. They're in your body. Do you know what they do?
They decompose? Or no, not decompose. They deconstruct.
They attack
Simple
healthy
enzymes.
cells. So if I took this hydrogen off, this would actually be called a free radical. Do you know what free radicals cause in your body?
Cancer.
They can, but not usually.
Disease.
Disease, sickness, aging. As you get older, what happens to your skin?
It gets free
That'd be
radicals.
cool, but no.
The free radicals.
What happens to your
slowly
skin?
radiate.
It gets wrinkly, dries out. It gets like looser or whatever. It's just
Looser.
gross way to think of it. Not as tight, whatever. Let's not get so weird here,
Looser.
but the point is, stay with me. The point is, your skin is a great example. That's what free radicals do. If free radicals didn't exist, people's skin would look a lot better until later in life. So, does anyone know what you're supposed to do? Do you know what you're supposed to do to
Moisturize
combat
your skin.
free radicals?
Moisturize your skin.
I was just about to say.
Inject white blood cells into the.
No.
combat that.
Yes, eat fruits and vegetables.
Wait.
Guess what they have?
Free enzymes. Or,
It's another like
Anti-free radicals.
antioxidants, right?
Yo, blueberries.
Antioxidants kill free
I
radicals.
was close.
So
What if you had no free? What if you just ate blueberries every day
If
and
you
you
want
never had a free
non-loose
radical,
skin,
and you were just the most healthy person in
eat
the world?
eat antioxidants all the time.
What if you just ate only? What if you had a strictly antioxidant diet?
Well, you need to eat other things. You could not just exist on fruits and vegetables. I don't think. You need some sort of grain or meat or something.
There's no
fish.
protein in fruits and vegetables. There's no like.
Minimal.
There's no fruit and vegetable that has high protein.
I don't know if you could survive. Anyways, back to this. We're not done. We're not done yet. Hold it. So the moral of the story, if that was not like a random tangent about nonsense, if you take one of these bonds off, this could call a free radical, and they don't really exist on their own, so they look to attack other things. So the point is, that's kind of cool to know about that in real life. But in here, why am I bringing it up? If you draw something without 4 bonds, carbon without 4 bonds, you're drawing a free radical, and that's not right. Okay, that's the moral of the story. So, real quick, just get one thing down.
So free radicals are bad.
Free radicals are real bad.
So you want to limit the amount of free radicals you have.
Limit the free radicals.
How do you increase the amount of free radicals you have?
Eat pretty poorly. Inhale a lot of toxins and pollution.
Yep. I'm gonna live in.
So you can do that.
China?
Write this down, please. What makes everything in this category
They
organic?
just have, like, seafood.
Carbon. Must contain carbon. Must contain carbon. That's the only thing I'm writing down. We're done.
Dude, you know what
I'll
I
be
found
right
out?
real
You know what I
soon.
found out
I guess
last
you
night?
don't have any homework.
You know why people in China live so much longer?
Yes.
It's because they eat like strictly organic diets.
You mean
And then you
Japan?
have chopsticks.
There's parts of
Japan
Japan
and
where
China.
people live.
No, in China.